Gotcha now. Should I start sharing my screen now?
Yes, you can start
Okay.
sharing your screen. Um,
Is it clear?
yes, it is. Give me a minute. I'll
Okay.
just start recording here and then I'll first introduce the program and then you can begin presenting. Uh,
Okay. My name is Mohamed Al Saif. I'm a master's student in the Health Informatics program at the School of Informatics and Computing at Indiana University. My capstone project is a prototype HIE model to achieve ONC vision for nationwide HIE. Health Health information exchange aims to make health information available for healthcare professionals whenever and wherever it's needed. Nowadays, patients receive healthcare from multidisciplinary healthcare professionals. Therefore, patients' EHR are fragmented among those healthcare providers. Since they use different systems, the fragmented EHR will create redundant health data and providers might have an incomplete health information. The background of the HIE in the United States started at 2004 with George W. Bush administration supported EHR and HIE by creating ONC that served as a strategic institution responsible for EHR relating planning. And it creates nationwide health information network that utilizes the internet to exchange health information. And also it creates regional health information organizations to facilitate HIE locally. In 2009, the HITECH Act was enacted, and it offered the first major funding to encourage healthcare providers to adopt EHR systems, which increased the HIE rate. In 2015, ONC published the Shared Nationwide Interoperability Roadmap that aims to encourage a nationwide learning health system that utilizes different communication channels to collect knowledge. The current approach shifted from a centralized approach to a decentralized approach. NWHIN rolled out RHIOs from being the primary approach for HIE in the United States. The current approach will take advantage of the NWHIN to diverse communication channels to transmit data. Also, it gives participants the freedom to use their preferred communication channel to exchange health information. The problem is with the ONC vision and how they can achieve it. The ONC vision of for HIE is that health information flows seamlessly and is available to the right people at the right place at the right time. The current approach has some shortcomings that need to be addressed in order to achieve ONC's vision. First, the technical complexity, and mainly the integration with other EHR systems. Currently, healthcare providers have a variety of EHR systems that either in-house or commercially developed that needs to interact with each other to exchange information. The second factor is the lack of technical expert in small practices. The second shortcoming is the ununified goals. Providers might prioritize their business strategy goals by limiting their HIE services to their business partners, which contradict with the ONC vision. And the final shortcoming is the inefficiency, which caused by the incapability to query patients' health data. Therefore, HIE cannot be effectively integrated into clinical workflow, and providers cannot allocate all the fragmented health information without a record allocator. And finally, there is the liability concerns. Studies reported that providers were conservative in sharing health information to avoid potential liabilities of breaching HIPAA. The, the objective of my project is to develop a prototype nationwide HIE model that utilizes the current infrastructure to meet ONC's vision and enable EHR systems to build longitudinal EHR whenever it's needed. The suggested approach to solve the problem starts with discussing the three HIE models that was tested and developed in the United States. First is the centralized model, which collects and maintains data from all healthcare stakeholders in a single data repository. The second model is the federated model, which is a shared approach that utilizes the current infrastructure of participants in a network. Each providers maintain their own database and granted access to their data for all participants. The last model is the patient control model, which make patients responsible to maintain and share their own health records. Among those three, only the federated model that showed a promised result. For the model I proposed, I believe that empowering RHIOs and adopting the federated model is a viable solution to address the current approach shortcomings. RHIOs are capable to reduce the technical complexity level, unify HIE goals, and enable querying patients' HR. And as I mentioned before, the federated model is the only model that has promising results. The developed, the developed prototype model currently RHIOs has sustainability issue, mainly due to the lack of funds and poor business model. Therefore, the responsibility and services should be limited. The proposed model in the proposed model, the current RHIOs will operate as record allocator that monitor, manage, exchange, and normalize health data. All RHIOs will have a mapping layer that map and reconstruct patients' health data. The mapping layer will have a single unified API that can be used by all e-health applications. The EHR will no longer be fragmented. A longitudinal EHR will be created, and it will be transferred permanently to the requester database when it's queried. The RHIOs will have an index. The index will include a patient identifier, a location of the recent constructed longitudinal EHR, and history of the patient's encounter. Each patient record in the RHIOs will have a pointer that shows the location of the latest longitudinal EHR created. When provider requests an EHR, the system will locate the most recent longitudinal EHR and add any new health information that is created after the creation of the longitudinal EHR. This will enhance the model performance by reducing the response time, which is a downside of the federated model. On the right side, we see an example. In the first example at the top, a patient went to hospital D, and the hospital requests his information from the RHIOs. So when the query went to the RHIOs, they locate the data of the patient, and they found there's two records in hospital A and hospital C, and there is no previous longitudinal AHR. So the regional health information will pull the information and construct a longitudinal AHR and deliver it to hospital D. After a while, when you see the picture below, a patient went to hospital C. So hospital C queried for the patient information from the regional health information. So when the request went to the regional health information center, they searched for the patient and they found out there is no longitudinal AHR before. There is no information. I'm sorry. They found out that there is a longitudinal AHR that's located in hospital D, but there is no new encounters after that. So they built the longitudinal AHR and delivered it to hospital C. The evaluation of my project has 5 domains. Each domain has a set of criteria, and each criteria has a set of measures. The first domain is the technology, and this domain covers the technical aspect of the HIE system and the user experience. It has 2 criteria: HIE system performance and user acceptance. The second domain is data, and it has 3 criteria. The first and this domain focuses on the data that is managed, stored, and collected by the HIE system. And it has 3 criteria: data quality, data availability, and data security. The third domain is implementation, and it aims to evaluate the HIE design, use, and implementation. And it also has 3 criteria: RHIO sustainability, number of participants, and clinical workflow. The fourth domain is policy, and it focuses on the impact of the local, regional, and national policies and regulation, and it has only one criteria, which is governance. And the last domain is value, and it concentrates on the impact of HIE on the clinical and population outcomes. And it has 7 criteria. First, impact on EHR, impact on HIE, impact on meaningful use, impact on HIT application, quality of care, patient safety, and finally, cost. The available health information has a direct impact on the perceived knowledge of all stakeholders in the system. Therefore, facilitating data exchange will be expected to have an impact on various aspects of the US healthcare system, and especially cost, quality of care, and public health. The expected impact on cost is improve clinical workflow, reduce repeated orders, improve productivity at initial visits, reduce hospitalization, facilitate telehealth services, lower communication costs, and utilizes the available infrastructure. And the expected impact on the quality of care will be as facilitate tracking over the counter drugs, facilitate data collection, enhance HIT application, facilitate care coordination, enhance patient provider communication, improve decision making process, facilitate home monitoring. And the expected impact on public health will be personalized awareness messages, accurate monitoring of the population health, EHR adoption rate, HIE exchange rate, and finally health surveillance. My project have three limitation. The first the main limitation is the participation of the key stakeholders. Without high participant numbers, the HIE will lose its value since it will give access to minimal and incomplete data. The second limitation is the data ownership. If the data is floating in the system and transmitting between multiple systems, then we need to regulate who owns the data. And the last limitation is the need for strong political support, policies, and regulation for transferring HIE data between states, and data ownership is needed to build an effective nationwide HIE. Thank you. And is there any question?
Thank you for the presentation, Muhannad. Does anyone have any questions?
Well, Hannah, this is Dr. Jones. I have a
Hello, Mr.
question.
Jones.
So you developed this prototype model and you explained very well why that new model is necessary. Do you see it to be implemented in the United States or more likely outside of the United States?
I don't think it will be implemented, let's say, to be honest, because currently there is a roadmap that is developed by the ONC, and the deliverable will be delivered, I think, at the end of 2020. So that's I don't think they will be likely will change their plan. However, the main point that I plan to develop this model is that the United States has invested on the regional health information system, and since 2009 they shifted their fund. They cut the funds and they shifted their model from centralized to decentralized. So all the investment on RHIO will be gone. So I think that we need to utilize the cost and reduce it by achieving this model rather than we follow a decentralized approach without creating a foundation level. But I think this approach will be more likely built if we when I start from the scratch from zero. It will be more better than do it right now.
So you don't see a buy-in from the decentralized health information exchange organization, like from iHigh, would they buy in to change to this model?
Yeah, I don't think so.
Thank you. Also, I want to point you out, you have no references on your poster.
Yeah, one of the example didn't have a references, so I don't think it's required. And as you see, it's a bit crowded, so that's why I removed it.
Okay. Any other questions? These are my questions.
Muhannad, I had a question about
Yes.
how do you think this relates to NWHIN? You mentioned initially that the current approach was to use the NWHIN. Are you planning to use the same standards, or
Yes.
what exact way for record sharing are you using? Or like what
Yeah. The
standard?
point, yeah, it will be the same standard. The point is that the current approach doesn't allow healthcare providers to query a patient. If you need to locate where is the patient record locate at and send a request and waiting for the response. So what I'm planning to do here is that allowing each hospital, if I want to access the patient information, I query it and I will have instant access from the regional information. I don't need to wait for a response from the owner of the data or where the data is stored at. So it will be the same standard and the same technical aspect they use right now. and the same certifications.
Okay, and what's your plan for sustaining? Is there a sustainability plan? Like, do you think members would be paying monthly fees? What's the plan for running the HIE or
Yeah,
RHIO?
yeah, I know. The RHIO funds, they say, was a bit limited, and they struggling with it. So the plan was in my mind. I didn't write it to my paper because I don't want to keep out. I want to because I want to keep my design high level. However, the initial thoughts about the sustainability is to allow that to the payers will be pay a fee to store the data for the RHIOs, and after a while, it will be we will not allow big hospitals to use the data to utilize it in any decision making process or any AI AI technology at a hospital unless they pay for the fees. So if any hospital want to do research or study about the patient data, they need to pay for it, or at least patients will have to use data banks, or they need to store the data by themselves.
Okay, thank you. Any other questions from anyone else? Okay, if not, let's congratulate Mohannad, and let's welcome the next person, Audrey.
Thank you.
Okay, can everyone hear me?
Yes, we can hear you fine.
Okay, thank you. Okay, so for my presentation, I pulled together my code. Essentially, my project was compiling a website for providers to use in order to gather more information about skilled nursing facilities. Kind of a problem that exists with providers, especially when patients are in either the emergency department or even inpatient, is what happens when a provider has a patient and wants to discharge them to a skilled nursing facility. If a individual comes into a hospital and is in the ED, and the provider wants to know, okay, well, if I discharge them, what type of care will they receive at their nursing home? So what I did was create a website in order to show this type of information. So I examined the importance of skilled nursing facilities within my literature review, and then was trying to find different data points that hospital physicians might use to determine what the best place is for their patient. This project was in conjunction with Dr. Josh Best. He was looking to include some of this information in either a current or future grant. And so I was helping him out with kind of the IT component of this, because he has his PhD in public health. So the starting information, what I began with was information about the CMS website. Let's see. This was the provider service file. One thing I did notice is that this releases once every quarter. So the APIs, in order to get to this data set, unfortunately have to be updated within the code every quarter, so long as the API doesn't have a unique ID every time, which from my experience looking at the current file, which is March 2020, to last year's file, they had different API IDs. So there was the CMS file, which then looks like this. When you look at one specific provider, this is in JSON. And then there was also the Medicare star ratings, which comes here. And this was this other file that I used to link, where there are several other data points available. So this was my code. I used JavaScript and Java and HTML in order to write this. A bit of background about me. I am a business intelligence developer and do report writing with SQL. So I have, before this project, never used Java or HTML. So it was definitely a good learning experience because it really pushed my knowledge and abilities. So basically what I did was I linked the data sets, pulled these pieces of information, recoded them, and then displayed them in a website. So this is what the website looks like. So in order to test the website, one simply must type in the ID of the federal provider, so, or otherwise known as the federal provider number. I have several saved here because I've tested this multiple times, and then select enter. Once that happens, all of these data fields will populate. For this particular example, the count of dialysis special care unit beds, it is indeed 0, and as is the Alzheimer's special care unit beds. I believe this one has multiple. This one has 16. The CMS star rating, I coded it to shade in the number of stars that CMS gave the skilled nursing facility. So this was the first facility that I looked at. Again, it shades in the number of stars. So what I thought was interesting about this facility is that not only does it have a CMS star rating of 1, this facility is located about 15 or 20 minutes away from my hometown of Springfield, Ohio. So I kind of thought it was comical that they appeared first on the list of facilities that are 1 star. This facility, Burns Nursing Home, has a star rating of 5. So that's pretty impressive by CMS. This facility did not have a CMS star rating available. So instead of displaying empty stars, I displayed the text, mostly because I could have displayed no stars. However, that might have kind of given the impression that the provider was providing very poor care. So I just decided to display the text instead. That is essentially what I did for the project and the build behind it. These are all of my sources. I did complete a literature review as well as part of the initial paper. I wrote the code over the last 5 or 6 months. Because I was so new to these programming languages, it took a little bit longer than I anticipated. So I split out this project over the spring semester and then this summer session. So does anyone have any questions?
Thank you, Audrey. You developed from no programmer to a programmer. So is this project been implemented by the Regents Reeve Institute at this time or not?
So it has not. I met with Dr. Vest, I believe it was last week, to show him the final project or final product, and then met with someone else at the Regents Reeve Institute. Currently, it is the goal of Dr. Vest to maybe eventually have this embedded within an EMR. Otherwise, if that's not possible, then make it easily accessible to providers. I will say that because I work directly within Epic every single day at a hospital as a business intelligence developer, it will take some work in order to get it directly embedded within an EMR, just because Epic doesn't really like to give up the control of that type of development. But I think it is an interesting goal and a great goal to kind of aspire to.
How will the providers find this code number? When I like to look for the site, how do I find? Because you put in a number, and to me that is not intuitive to put a number in it. I would like to see more nearby within so many miles instead of enter the number.
So I had considered that. In terms of the search, you, like you said, have to insert the federal provider number that is found, is essentially the primary key and foreign key in the two data sets. So I agree that it is something that most providers aren't necessarily going to know off the top of their head. However, with the kind of capabilities that I had and knowledge going into this project, I kept it simple for the first round to have it searched by provider ID rather than provider ID or a name set like something or a zip code. Partially because I've realized all of this is case sensitive and the files are a little wonky in how they display information. So for my limited knowledge and coding abilities, I use this as a starting point. Perhaps if this ends up going further, I can help Dr. Best use this code and develop it more to be more user-friendly to providers.
If you plan to do a usability test, what are your criteria to evaluate the website?
I'm sorry, you kind of cut out for a little bit. Can you repeat your question?
So if you plan the usability test, what are the criteria, benchmarks that you will be used to assess, yes, this is a good website, to give yourself 1, 2, or 3, or 4 stars?
So are you asking whether or not the provider is considered a, like the
No,
nursing facility or my website?
If you ask users to use the website, how will you find out that your website is what they want to?
Okay, okay, now I understand your question. I apologize. So initially, I kept it pretty basic. Obviously, it is a pretty simple font, a light background. The kind of biggest wow factor that I coded was the overall CMS rating with the stars appearing. In terms of kind of physically appealing website for providers, I would definitely welcome their feedback. Knowing that this might eventually be used towards or embedded within an EMR, I kept the code pretty simple because, again, Epic and other EMRs like to develop their own kind of user interface. So when I use the code, I think that the light blue background would probably be removed as would a few other things. So I kept it more basic in order to display the functionality of the website rather than kind of the physical appearance, if that answers your question.
Thank you.
Are there any other questions?
I had a question about this ID that you're entering. If I was using an EMR, I would probably use the NPI, the provider identity number that's required for every HIPAA compliant transaction. Why do you use this CMS specific ID?
So the ID that I used was a federal provider number. As far as I know, as from the NPI ID, I believe that actually applies to clinical providers like physicians or nurse practitioners and such. I don't know if it also applies to facilities. That is just a limitation of my own knowledge. Mm-hmm. But if it does apply to facilities, essentially it wasn't in either of these data sets. So I would then, if I were to use that, cross-reference it in a table that would say one column of the NPI ID and then another column of the federal provider number, because the federal provider number was the same ID in both tables or both data sets.
Mm-hmm. Yeah, the NPI does provide organizations also, and it's sort of a requirement from the legislation to include that in every transaction.
Okay, that is interesting. I'm wondering if, obviously there are quite a few columns in this data set, so I'd be interested to see if it is in this data set somewhere, the NPI ID. I did not see it in the star ratings data set. So again, I would, if I were to use the NPI ID, which would obviously be easier for providers to find because it is in other transactions as well, I would have to create a table to cross-reference the two IDs.
Okay, thanks.
Are there any other questions?
Please don't let Dr. Pukayasta and myself be the only one who grill you all.
If you had a unlimited time budget, team of programmers, are there other features that you'd want to bring into this besides, say, searching by zip code?
So if they could search by zip code, that would be obviously multiple results per zip code. I would also be able to search by name, phone number even. Honestly, if I had unlimited resources and much more knowledge regarding JavaScript and other coding languages, I would honestly like to create a box, which Dr. Best had originally requested if I was able to do so, kind of create a box that said general provider notes. That way, if this was embedded within an EMR, a provider could say, well, the phone number listed is 772-546-5800, but the best number to reach is actually this number instead, because this is a direct line to the nurse's station within that skilled nursing facility. So there would also kind of be implications of that as to where to store that information. I'm not writing to a specific location with this code. I am kind of using the code and getting information from CMS. So that would kind of pose a different issue if I were to have a text box that said kind of tips and tricks for providers to annotate within their EMR. Does that answer your question?
Yeah, very cool. Thank you.
Are there any other questions?
Okay, if we don't have any questions, let's congratulate Audrey for that presentation and move to the next one, which Hanisha is going to do. Hanisha, are you ready with your presentation?
Yes, yes.
Okay.
Can you hear me, everyone?
Yes, we can hear you.
Thank you. Good evening, everyone. I am Hanisha Desu, and I would like to present my project, Classification of User Roles Based on Their Posts in an Online Breast Cancer Community. The main aim of our study is to classify the users in an online community, breast cancer forum. So the main reason behind my objective is, in recent days, all healthcare organizations and researchers are increasing their interests in text classification and NLP to use the information available from the text to enhance the quality of care. Information shared through these kind of discussion forums may include useful information that can be utilized to enhance the quality of care. However, we have methods for text classification, which is easy up to 50 to 100 documents with a limited text. But however, if it crosses more than 100, it will be laborious and potentially unreliable to work on. So in our project, we are going to discuss some machine learning models that facilitates the text classification. Moving on to methodology, breast cancer is a great platform for, my data was extracted from the breastcancer.org database. So the breastcancer.org is a great platform for breast cancer people and their families to share the stories. Initially, we have extracted 500 users' data, which include 18,566 posts or rows of data. After looking at the data, we discussed and finalized to start from supervised models. All supervised models need to have some labels, but our data has no labels. So we plan to annotate our data with 2 annotators for the validity purposes. However, annotating 18,000 rows of data is laborious. So we picked 10 posts per each users and start labeling them. Before annotating data, we have defined some characteristic for each user with the help of our literature review. And the labels from the two annotators were cross-tabulated using the SPSS statistical tool. If you can see the figure table 1, it's a cross-tabulation between annotator 1 and annotator 2. Here we got a 5.71% of disagreement. That means 103 posts were misinterpreted by both annotators, and 0.871 Cohen's-Kappa value, which indicates a perfect agreement between annotators. After getting a labeled data, we performed some exploratory analysis such as a distribution of classes. If you can see figure 2 is that an imbalanced class distribution between 4 classes. We have patients, family members, others, and moderators in the breast cancer forum. So the graph indicates that the data was very imbalancedly distributed. The main outcome of our project is to differentiate patients from all other classes. So we decided to combine all the other classes like family, others, and moderators into non-patient class. So then we plotted again a distribution curve, which indicates that still imbalanced, but it is better than the previous one. So moving on to the feature engineering. Feature engineering includes text cleaning and text representation, where text cleaning is nothing but data cleaning, but text contains a lot of unwanted characters. We want to remove them because they don't contribute any of the in classification. So we try to remove it with the help of Gensim package. I have removed all the punctuation characters, articles, and stop words from the data. I lowercased all the words and all. After text cleaning, I moved to text representation. Text representation is mostly explained as feature extraction. So for usual machine learning models, attributes such as age, gender, socioeconomic factors, demographic factors are all considered as features. But for text data, features has to be extracted from the text. For my study, I have used TF-IDF scores for feature production. So TF-IDF scores means nothing but it represents the term frequency for a post and its inverse document frequency of words. In order to produce efficient features, I have took top 5%, 10, 15, and 20% frequent words in the whole data to avoid terms that appear only once or twice, that words don't contribute in classification. These TF-IDF scores are extracted for each label, and these 4 models were used for classifying. And moving on to the model deployment, the data has split into 70-30 random ratio, test and train ratio, where 70% of my data is used to train the model and 30% is used to test the model. And after training a 70% data with logistic regression, SVM, and naive Bayes, with all the 4, 5%, 10%, 15, and 20% models, it will be able to classify the patient and non-patient classes. So, however, we don't know whether they are classified accurately or not. So therefore, our classified data will undergo some evaluation metrics such as confusion matrix, PRC curves, and F1 scores. Here, confusion matrix is nothing but a combination of actual and predicted values in the form of true positives, true negatives, false positives, and false negatives. And the figure 4 and 5 indicates the, these are the figure 4 and 5 are the confusion matrix for our models. So figure 4 is the logistic regression confusion matrix for 20% features. So it indicates that patients are classified as patients accurately. If you can see the bottom right corner, it says 667 patients. They are the patients who classified as patients correct. And if you see the top right corner, 93, number 93 in the blue color, it says the non-patients who are classified as patients. But still our model is nevertheless better compared to the all other models. And the SVM confusion matrix for top 20% features also kind of showed the same results. It was able to predict the patients as patients, but however, it was not able to predict the non-patients as non-patients. It just predicted as patients. And the precision recall curves for that two models is given below. Precision and recall are two worthy evaluation metrics. Precision describes the goodness of a model that predicting the positive class, whereas the recall states the percentage of total significant results which are not, which were correctly classified by the algorithm. And these PRC curves explain that explains the trade-off between the true positive rate and the positive predictive value. Here the figure 6 indicates the precision recall curve for the logistic regression with 20% features, and figure 7 represents the precision recall curve for SVM with 20% features. The curves indicate the y-axis is drawn with precision and x-axis indicates recall. The curves look pretty good, and I can say by using the AUC of PRC curves, the SVM and logistic regression has performed pretty well compared to the naive base. And moving on to the F1 score, the F1 score of 0.83 for model SVM with top 20% features indicates that the model performed well. However, all the models produced like similar result, but confusion matrix is the best to evaluate the best model from all the 12 models. And through this study, we laid out a strong foundation for text classification with machine learning model. Nevertheless, the model performance was a little bit satisfactory in differentiating patients. This satisfactory results might be due to the size of our data. We limited our project to 500 users only. This might be one of the main drawback, and the other limitation for our study is the distribution. For any class distribution is very important for any classification problem, but our data has very imbalanced class distribution. This might be one of the problem. And future work includes like we need a better classifier with greater performance than the achieved model. So deep learning models such as doc2vec, word2vec might produce better models, which can be considered as a future work. And annotating more data, like we have annotated 500 users. So annotating more data can help us producing better results than the achieved one. And that's it. Thank you. Any questions?
So this is Dr. Schwebach. Why these three models? Did you try? And I may have said this and I missed it. Did you try other AI techniques and came to these, or were these the only three you tried? What can you explain kind of that process?
Yeah, we have limited our project to only machine learning models. So I've chose this SVM. Logistic regression and naive Bayes because my literature review says that SVM is the best text classifier, and logistic regression is best for doing a binary classifier. Mm-hmm. So I chose logistic regression and SVM for that, and I want to compare the naive Bayes, which is naive Bayes is a simple method. So I want to compare the results between naive Bayes and logistic regression and SVM. So it turned out, surprisingly, everything came well, but SVM performed well compared to all other models.
So what is the trade-off between the difficulty of using it and the simplicity versus the results you got? I'll rephrase that. Is there, pardon me, if one is easier and gets almost as good a results, what is that tipping point to decide you to go from the naive Bayesian to the SVM? What?
I thought SVM would give better results than the naive Bayes, but it turned out they kind of showed similar results, but SVM has produced like a 0.97 value of AUC, which means it's the best value.
Okay, thank you.
Any more questions?
I want to ask a question about your confusion matrices. So the two confusion matrices you showed, they look like that your model almost exclusively predicts the positive label. I think that's part of it. Part of the reason is that you have a very imbalanced data set, but have you thought of other ways to improve the performance of these models or other ways to represent your data sets?
No, I thought of doing oversampling, but it may lead to overfitting. That's why we dropped that idea of oversampling. So the deep learning models like Vertivec might give better results than these. These are due to the imbalance distribution. As you said, it was because of the imbalance distribution. Sorry, did I answer your question?
Yeah, that's sort of, but what I want to say is you can, like these other metrics, precision, recall, you can compare them with, you can compare the performance among different models, and you can say one performs better than another. But looking at your confusion matrices, how do you think your model can work, say, in a real world scenario? Because right now, by looking at this matrix, I think it's so only 4 or 5 out of 700 or so examples are predicted as negative.
Yeah.
Like how useful are these models?
How confusing matrix? I didn't understand your question. Can you repeat it?
Oh yeah, sure. So if you look at your confusion matrices, it's like about 95% of the time your model predicts the positive label. Right, that's almost a deterministic classifier in some sense. So how do you think this model is going to be useful in some real data sets where you need to predict, say, the different types of users?
Oh, yeah. I'll not say that I can use this model in real data sets, but our study includes Vertivec, but due to the time constraint, we haven't worked on the Vertivec model. So we included Vertivec model as our future work. I guess Vertivec or neural networks may work better than the machine learning models for this kind of data. This is just the basic foundation step for doing text classification. So, did I answer your question?
Yep, thanks.
So can I ask a question?
Sure.
Or give a comment? So Anisha, you did kind of like an exploratory study from which models, which techniques can I use to classify users in a forum if I don't know what they are? And so you based yourself on the literature to limit you to the extreme models. But like you said, your data set was really unbalanced and you went by users, would your data set not be more balanced if you would have looked at the post and that some people can function different at a different time?
I
So instead of a person is a patient or cannot be anything else. But if you look at the post, the individual post, do they always post as a patient or not?
No, I understand. So we have like 500 users, have like 100 to 500 posts for each user. So in every post, patient will not explain him as a patient. So sometimes he'll just talk about something.
You are going away for me. I don't know if it is the same for others too.
Can you hear me?
Yeah.
So yeah, the patient, patients will not always exhibit them as patients. They'll just discuss like about books and all. So in some posts they don't represent like a patient. They represent like some other categories. So what we have done is we have annotated the post according to users. If I annotate the post according to posts, that can give me positive results. Like it can differentiate the non-patients as non-patients, but in real-time use we are just trying to differentiate users, not posts. That's why I considered to label by users. Did I answer your question?
Yes, thank you very much.
Any more questions?
Okay, I think we are done with time. We need to move on to the next one. If there are more questions, then please feel free to send an email to Hanisha or Dr. Jones, Nandan, Chakrabarti, and Edming by including the project team on this. So thank you for the presentation. Let's move on to the next person, who is Ramnik. Can you share your screen? Yes.
Can you hear me?
Yes, we can hear you.
Good evening, ladies and gentlemen. My name is Ramneet Kaur. My Capstone project was based on my current job as a registration specialist at IU Health Physicians Neurosurgery. My project is the implementation of self-service kiosks in adult neurosurgery. Over the last decades, technology has transformed many industries, including healthcare. Technology has majorly changed healthcare by developing applications such as electronic health records and patient portals. It has been able to reconstruct provider and patient workflow, build more connections, and improve quality of care. It was my goal to incorporate the use of technology while being HIPAA compliant, reducing costs, increasing patient satisfaction and communication when patients are present in outpatient clinics. As I was working in the clinic, I realized many patients were becoming frustrated with employees when checking in for their appointments, especially if they were established patients with the practice. They were repetitively verifying their demographic and insurance information aloud with a waiting room full of strangers. Therefore, the purpose of my project was to increase patient satisfaction and encourage health communication through technology for patients to get involved in their check-in process while being HIPAA compliant. The implementation of kiosks would be beneficial in most aspects for the patients of neurological surgery. To get started, I met with the department service line administrator for background intel on the clinic, such as age, race, gender, location, and insurance payer information to get a better understanding of the clinic's patients. She also provided me with great details on how the budget would work for a project like this. The budget must take into consideration how kiosks will serve as a better purpose for the clinic financially when it comes to offset costs as well. For example, the clinic manager was able to provide me with information on how much is spent on forms, which is $2,500 annually. Cutting out the usage of paper simplifies the workflow for employees as well. Simplifying the workflow for employees benefits the clinic to the point where they can be more interactive with the patients on where it is solely needed. Throughout the literature review process, I had found that self-service kiosks have many benefits to them for outpatient clinics. For example, the article, Data Requirements and the Basis for Designing Health Information Kiosks stated that the experience of leading organizations has shown that kiosks increase patient satisfaction by reducing wait times, providing better service, and maintaining more privacy. Many of the articles provided great insight on how it has positively affected clinics when the implementation of kiosks occurred in certain outpatient clinics. I began to differentiate the three different possible ways of check-in. Many of the capabilities from each form have their advantages. Their traditional method is conducted by an employee verbally asking all demographic and insurance information allowed to verify if it is still accurate and correct and current. This is the current process of all outpatient clinics and IU Health physicians. Patients are required to check in with a staff member at each and every visit. The self-service kiosk would allow established patients to check themselves in by going through each step electronically to ensure it is current. The patient would first have to identify themselves through a protective method. Then the patient must verify their appointment, demographic information, and insurance to ensure it is active. Third, a tablet with a built-in app could also allow patients to take a seat with a mobile device to check themselves in, similar to the self-service kiosk. The Institutional Review Board commenced the research by granting an exempt protocol for the study of exploration and utility of usability of self-service kiosks. The process was very tedious to warrant the safety and privacy of patients throughout the study. Due to COVID-19 pandemic, patients were mostly seen virtually. Therefore, patients must be pre-registered via telephone prior to the visit with their healthcare provider. The survey took place at the end of the pre-registration. Patients over the age of 18 must have consented for the questionnaire to begin. Patients were asked a series of questions to get their opinions on their previous check-in experiences. 94 patients were consented and were surveyed through this process. It was critical for the survey to prove its reliability and validity. The requirements included is a question specific. How will the question affect the study? How will the subject react? Therefore, I presented the survey to fellow coworkers and the clinic manager for it to be criticized to see if we are able to test the patients to their full capacity and capabilities. The results showed that the survey was able to represent the clinic's needs when it comes to quality improvement for check-in methods. 43% of patients answered content when they asked how they would feel about checking themselves in for an appointment. Also, 62% of patients preferred the self-service kiosk over the traditional method. The outcomes were conclusive. The survey outcomes were conclusive. Majority of the subjects were from the age group 18 to 40. From the patients who were 65 and older, only 4 out of the 94 participated. Patient satisfaction and health communication were tested thoroughly within the survey. For example, health communication must be synchronized for patients to understand the technology used within healthcare. The use of technology becomes a versatile component. It further educates the patients on becoming more connected with their health information. Quality improvement is critical for healthcare management to understand when pertaining to a patient's health information, education, and their privacy. The evidence presented would suggest that patients prefer a quicker method of check-in. Many believe the traditional method is not HIPAA compliant as staff members verbally ask demographic and insurance information, which implies a change is needed to ensure privacy. Also, provider surveys and feedback were not taken into account for the study. However, I believe it would have been very beneficial for the feedback of healthcare providers to create a positive impact for the enhancement of patient and provider relationship when it comes to education and communication for the patient. Patient satisfaction can further be tested with the implementation of self-service kiosks with the proper education and communication. The results showed that the patients are interested in learning more about the technology, especially the newer generations. Quality improvement is needed to increase satisfaction levels as more providers are being added to the practice of IU Health physicians neurosurgery. Correspondingly, the survey assessed the patient's perspective on using technology. In conclusion, involving patients in their own healthcare has become an important aspect for many organizations. The literature review provided a comprehensive understanding of the self-service kiosks' backgrounds. The components shown through the literature review were immensely impactful when it comes to how significant health education and patient involvement can truly be. How healthcare organizations must concentrate on patient-centered care. The process begins by involving patients in their own healthcare to be able to improve the quality of care. Although feedback from the patient surveys established a foundation for the process of implementing self-service kiosks, health organizations must provide a first-hand experience with the hardware and software. However, patient satisfaction has the opportunity to increase with the implementation of kiosks as it intertwines with the progressing health education and communication for patients. Any questions?
Great presentation. Did you have any, like what the user interface of the kiosk look like? Do you have that?
No, I do not, because when I discussed with the service line administrator, if I could see an example, she said she reached out to HR and to many other outpatient clinics within IU, and she mentioned that no outpatient clinic in IU Health Physicians has a kiosk.
Okay.
Did you see any difference in the acuity of the patients in when analyzing the efficiency and how pleased they were? Or was that something you were able to look at with this survey?
Yes, I noticed from the elderly patients that there was a big difference. Many from the age from 18 to 30 were more compliant with their information and how we were saying them out loud. All the elderly patients tend to get irritated to hear us verbally ask the questions. So I noticed a big difference between the age differences.
But no differences in what they had come in for the service they'd come in for.
For the service that for the service that they would come in for, I've noticed that more patients who have spinal injuries get more irritated because they have to stand and they have to stand next to us for a good minute before they could sit down. And when they do sit down, we would have to, again, about the forms, we would have to hand them forms and they would have to fill out those forms where to the point it was like 3 to 4 pages, and they would get irritated to ask why they were writing everything down when it should already be in the system. Because the ones that are in pain, they just want to be seen to that point.
Okay, thank you.
Hi, this is Kathy Fulton. I have a question for you. I'm looking at your survey question number 3, and if I read that correctly, 88% were pleased with their previous check-in process. So why would the organization want to change the check-in process if 88% were happy with it?
I guess that would become to the point where 4 out of the 94 patients were 65 and older. So that I believe that the younger generations are more compliant to how the process is, because it could be quicker at sometimes, especially if they're an established patient within the practice of IU Health. They tend to just be like, yes, all of our information is the same. And they just want to take a seat at that point.
Thank you.
I have a follow-up question on that. So, Ramnik, we discussed early on, did you consider other check-in systems besides the kiosk where this group of patients have to stand in and answer the questions, like a tablet or anything else, so that they can sit down or do it at home if needed?
Yes, so since COVID has happened, I learned about the app Virtual Visits, with IU Health. And I believe that as we could eventually incorporate the check-in process, because everything can be done virtually, like even talking to a nurse within that app. So I believe as time goes on and technology advances, we could, within IU Health, especially IU Health physicians, because there is no other method besides the traditional method, that we could add in using a tablet with a similar interface that could be used on a kiosk.
And next, what you brought up earlier, that most of your patients who have problems with it are 65 and older, and with spinal injury, because that's the clinic where you work. So why would you not adopt your check-in method to, or be flexible to also cater to this group of patients? Because I don't think that those group of patients will do it from home either, even if they can do it from home with a tablet, because they are not inclined, they don't understand, or they will say, oh, I do it later. They can ask me the questions and I will answer them. Have you considered how to solve that problem?
Yeah, I believe, especially with a different group of patients, such as traumatic brain injury clinic, or TBI clinic, most patients always have a family member or a significant other with them that usually help them check in. So the patient tends to take a seat and the family member can verify their information, especially if they are on their HIPAA form or their communication list, which acts as their HIPAA form, which we can see prior to their check-in. That's only if they're an established patient, though. If they were a new patient, they would have to fill out all those forms.
I have a quick question. So were all of the patients that were visiting the neurosurgery clinic eligible to be checked in with the kiosk, or was there specific parameters that prohibited people from being eligible?
So I would believe the criteria would be that they have to be an established patient with the clinic, meaning that they would have already been seen prior to our opening date, which was our adult neurosurgery officially opened last year on 9/1. So it would have to be critical that they have been seen within that time frame. So they have already been seen by one of our providers, because our criteria may be different than a different clinic, such as ENT or pain management.
Okay, thank you.
Hi, I have a question. So this is Sunandan. So I'm looking at, though you have only presented a sample of survey questions, the answers are very broad and generic. So like, how was the efficiency of the check-in process? Like, did you get a good understanding for the people who did not give like full score, like excellent or very good? Did you get a sense that what was not efficient about this process, like that would help you to better implement, better design the kiosks?
That's a great question. So even when we were pre-registering patients, we couldn't differentiate which patients have been seen in clinic during the COVID process, because my interviews took place during for virtual patients who have been seen in clinic, which providers thought that they could be seen virtually. And so since they were being seen virtually, when I would call them, you could tell from their just the voices that they would be like, all of our information is the same, or just the annoyance that they would get from repetitively verifying their own information. When their information, of course, they have not moved within a certain time period from when we last called them to their next appointment. So I could tell that irritation from their voice and how they would be not happy with verifying their information again.
Okay, so some qualitative information were recorded. It wasn't recorded as part of your survey.
No, the IRB did not require me to record.
No, when I said recorded, I mean like you used that information.
Yes.
Okay, thanks.
Okay, I think we're done with all the questions. Thank you so much, Ramnik, for the presentation. Let's move on to the next one. Shia, are you ready?
Hello, can you hear me? Let me share
Yeah.
my screen.
Yes, we can hear you.
Let me see. Oh, sorry. Okay, my name is Xia, and my project is about the machine learning. I use machine learning methods to predict the depression occurrence with alcohol use and social demographic factors. So the alcohol use and depression are two common social and health problems for US adults. Much evidence demonstrates a chance of co-occurrence with these two conditions. One study from 2015 indicated that major depression is suggested as the most significant comorbid psychiatric disorder in people with alcohol disorders. The relationship between depression and alcohol use is viewed as causal in nature rather than random overlap. However, the etiology and underlying mechanisms are unknown these days. So I try to use machine learning methods to find the links between depression and alcohol use and other social factors. Also, in this project, I compared different machine learning models with the performance. So 4 out of 6 methods showed strong predictive values on depression prediction. This study aims to provide the links between adult depression and alcohol use with multiple variables to analyze and compare machine learning methods performance to demonstrate machine learning as a predictive tool for health informatics students, researchers, clinicians in the future. So the dataset I used came from the Substance Abuse and Mental Health Data Archive, which aims to reduce the impact of substance abuse and mental illness. This was sponsored by the US government. The study used the National Survey on Drug Use and Health 2017 to train multiple machine learning models. The models include the Google multi-class model, which is a default model on the Google Cloud platform. I also trained the random forest, support vector machine, GlamNet, Treeback, and generalized linear model with RStudio and the package Carrot. So the data set itself contains around 70,000 interview responses obtained for 2017 survey, and the weighted interview response rate was 67.12%. My 6 alcohol-related independent variables are ever had drink of alcohol beverage, alcohol age of first use, alcohol frequency past year, alcohol recency, alcohol frequency past months, and bench alcohol frequency past months, and 5 social demographic independent variables includes gender, marital status, educational level, employment status, and family income. And my 2 dependent variables were lifetime major depression episode and past year major depression episode. The data cleaning and was a statistical imputation, which was already finished by the creator of the dataset. So there were no missing data for my machine learning training. Also, I normalized all the data value with a range from 0 to 1 to train my model. The evaluation metrics included AUC, PR, AUC, ROC, accuracy, kappa, precision, sensitivity, specificity, and FOS score. The first figure here shows correlation, variable correlations. Let me talk about more detail about this figure. So the frequency of alcohol use, educational level were negatively related to the depression, and the educational level was strongly negatively related to the depression occurrence. Marital status, employment, overhead alcohol use, and alcohol recency were positively related to the depression occurrence. Family income, gender, binge drinking have no obvious correlations with the depression occurrence. For the machine learning part, I have 4 tables to describe the performance. The first one, Google multi-class classification model, had nearly perfect values on all metrics. As you can see, the AUC is 0.995 and 0.976, with all other metrics very close to 1. And all other 3 models, random forest, GlamNet, and Treebex, have the accuracy above 0.95, which were strong predict values for these models. So for the discussion, the links between alcohol use, social demographic status, and depression. So we can tell the educational level was the best indicator for depression occurrence among US adults in 2016. Because the data was published in 2017, the data actually show the results for 2016. So for US adults, the higher the educational level, the fewer depression episodes, both in 2016 and over a lifetime. Clinicians may consider a new patient's educational level background as a factor in depression treatment. Although we cannot change a patient's educational level, but we can make a holistic care plan to treat people not only by the medications. We can also include some other methods such as support groups. Machine learning methods analysis, while performing models such as the random forest, GlamNet, Treebeck had average prediction accuracy above 0.95. The simplest model, a Bayesian generalized linear model, showed an average accuracy of 0.7 on both predictions, which proved that advanced machine learning methods are actually better than a simple linear model. There's some possible applications. This project actually shows that machine learning has the potential to explore healthcare research questions from a new perspective. You actually can study other substance-related topics through the same data set and through the same methods. However, to use a third-party service such as Google Cloud Platform, healthcare data privacy and security would be a concern for healthcare settings. Based on the literature reviews, the project was the first study that used both an SDUH dataset and a machine learning method to find how alcohol use and the social demographic status are linked to depression. Correlation and variable importance analysis identified the relationship between variables. Also, I forgot to say, in the random forest model, I checked the importance of the variables. Educational level had the greatest impact on the final prediction. And students and researchers may use the links to conduct more studies related to the depression occurrence. High predictive volume models and customizable survey questions showed the potential for using machine learning in real-life settings. So as a student or clinician, if you are interested in machine learning, you can conduct your own survey by referring the NSDUH questions. And also, clinicians and healthcare informatics students may be able to use these models with basic knowledge of machine learning and healthcare data to develop their new models for their own specific research questions. For me, as I only have a background of nursing without any informatics skills. With the skill I learned from this program, I'm able to train my own machine learning models. I think it's doable for other students with the same background. Yeah, thank you.
Thank you for the interesting presentation, Chia. Does anyone have any questions?
Shea, this is Dr. Schwabach. I noticed that you don't have a limitations section, and we talked about that. Can you kind of cover some of the limitations you see to this?
Yeah, the model itself cannot be reused for your own purposes. So for your own settings, you have to gather your own data, do the cleaning, and gather the features to train new models. So those models are only usable for depression occurrence prediction in 2000 for maybe 2018, but cannot be used for specific settings. So, but the method itself can be repeated.
Thank you for the presentation. I have a question. I maybe missed it. How many social demographic factors did you use? I heard education, but which other social demographic factors were included in the analysis?
Other 5 independent variables are gender, marital status, employment status, and family income. However, only the educational level are strongly correlated to the depression occurrence.
Hi, this is Sunandan. I have a question. So did you notice any, like in the data, any gender bias or racial bias? Did you have information about race in this data set? And do you see any misuse of a model, like introducing racial or gender bias or any other potential misuses of a model like this?
You mean for the data set itself?
First, yeah, my question is targeting both the data set. Did you notice any kind of bias in the data set, whether it was heavier on on the gender or on race, or then about the model, do you see that this predictive model can be misused in some way?
Yeah, for the gender, the data sets only include 2 categories, male and female. I don't know nowadays, some people want to think about other options about the genders. Also, some misuse, maybe the description about the alcohol use was limited by the time you use in last month, something like that. So maybe they can provide some more symptoms related to the data set. So the misuse about the machine learning methods, they may be too confident in these methods, something like that, yeah.
Sorry, Kathy, do you want to go first?
I do have a question. Thank you very much for your presentation. So you can take a deep breath because there's no right or wrong to the question that I'm going to ask you.
Okay.
Okay, so I want you to think back to January. And if you could go back to yourself in January and give yourself advice for your project, what would your advice be to yourself going forward?
Well, I think I will choose the data set from 2018 first. That's the latest version. Also, I would do some more statistical test about these variables, not just correlation. But it took a long time for me to learn the machine learning from the beginning. So I'm glad I am able to train those models by myself. Yeah.
Thank you.
Thank you.
So yeah, great presentation. I was confused in what this Google multi-class model is. Is that like
That's
the auto ML?
described by the model by the Google itself. I use the Google Cloud Form. They
Is
have
that
a machine learning.
auto ML?
Uh,
Is the product called auto ML, or how do you do that?
You just need to upload your cleaned data set as a CSV file. The Google ran the model for you, but it costs money though. I get my free credits, $200, so I use it. So.
Okay, and for the other ones, did you use some kind of cross validation for how did you select the parameters for many of these?
Yeah, I try to keep the parameters simple. So I search from the carrot package. I select the models without the other turning parameters, like the SVM model I use with a linear kernel instead of a poly kernel. So I don't have to turn the parameters for the model training. So I try to keep it as simple as possible. So.
Okay, thank you.
Yes, thank you. Thank you, Dr. Cassie.
Do we have any other questions from anyone? If not, let's move to the next presentation. And I think we have Sunil who's going to make the next one. Sunil, are you ready? Sunil, we are not able to hear you if you're saying something.
Yeah, can you hear me now?
Yes, we can hear you now.
Okay. Oh, just a moment. So the main aim of the study is to identify similar studies in the clinical trial database using the inclusion and exclusion criteria, that is eligibility criteria in the trials. Coming to the introduction section, randomized control trials recruit patient on the eligibility criteria. So eligibility criteria, it specifies the participant characteristics required for screening and recruiting process. So retrieving the information from the clinical trial database is very difficult as the data as it has information overload.
I'm really sorry to interrupt. Would it be possible to full screen your poster? I can't read anything. Can't see anything.
Okay, sorry. I just wanted to zoom and show everything. Can you see it now?
Much better, thank you.
So eligibility criteria, it specifies the participant characteristics required for screening and the recruiting process. So as information overload remains a significant barrier in the clinical trial website, it is tough for the patients and researchers for sites the clinical trials online. So coming to the informatics problem in this topic is that eligibility criteria, like it is hard for a patient and researchers to investigate the similar trials from a large data and check for eligibility criteria for the trials. So there should be a solution to retrieve similar trials related to the document when one document input is given. So the main objective is that to learn the vector representations of the clinical trial data based on the free text eligibility criteria data. So in order to pursue the objective, the main thing was to cluster the trials based on their similarity eligibility features. Coming to the clinical trials GOV, clinical trials GOV is a database which stores clinical studies information all over the world. So currently it has 337 and 371 research studies from different 211 countries. This website provides information on the status on the ongoing studies, whether the patient recruiting or not. The methodology followed in this to cluster the clinical trials of the eligibility criteria is that downloading the all clinical trials which are present in the data and extracting the eligibility criteria from the clinical trials, and just mainly our focus is on to extract the eligibility criteria. So we have extracted the eligibility criteria, and then further data processing, and as my goal is to cluster the trial, so implement the methods, different methods on the data, and finally compare the results between the existing and the new models. So in order to process the data, the processing steps included sentence boundary detection and identifying the sentences, then tokenizing the words and removing the stop words, special characters, punctuations, and converting the words into the root terms, and also process the clinical data. So in order to achieve this, in order to perform this task, so like I have researched a couple of word amending methods. So nowadays, word amending methods have gained a lot of popularity. So the best thing with the word amending models is that it can transform text to machine readable languages, that is numbers. So these representations of words in a vector space help it to learn algorithm to achieve better performance in NLP task by grouping similar words. So that's the reason I have choose the word amending method. So have researched couple of word amending methods so that I have found word to wake, fast text, and glow, which are the existing word amending models. So what these algorithms do is that these algorithms scan the corpus within a fixed size window. So as our goal is to cluster the clinical trial documents, like every clinical trial has a tag to it. Example, each clinical trial has a document tag to it. So on researching the word to wake model, so I have identified a doc to wake model which especially trains the algorithm by sending a document with a tag. So doc to wake, it helps in identifying the relationship among the words and also understand the semantics of the text. So in doc2vec, we have two different types of doc2vec models. Like one is distributed memory model, and other is distributed backup words. The main difference between these two models is that one of the it's the main difference is the hyperparameters. So and the training which they train the data is also different. So the distributed bag of words trains the paragraph vectors and try to predict the other words in the paragraph, whereas distributed memory model looks the problem in a different manner. In this distributed memory model, the context is in a fixed size window, and the target is a word that comes next. So it trains the 5 words and try to predict the next word. After passing into these word to wake models, our next step was to cluster the trials based on the similarity. As this is an unsupervised problem, we have to choose a clustering unsupervised learning algorithm. So have choose a k-means clustering algorithm because it is the simplest unsupervised learning algorithm, and it solves a well-known clustering problems. So coming to the input to the doc2vec model is given as a document with a tag, and as a tag document, and there will be one unique vector for each document during the training. So the documents are all the documents are trained into distributed memory models and the distributed bag of words models. So and the model is saved. So the next task was to clustering is done on the train models. These are the results for the clustering, and so after I figured out that there should be a good there should be some comparison models which should check the performance of the performance of this model. So in order to do that, I have went through a paper and find out the baseline model which where the author doesn't use any kind of new models, and this is a paper from 2014. So in that model, the author has used a meta map and extracted the only clinical terms and extracted the and clustered the data using the medical concepts that have been extracted. So after extraction, after clustering the data from the different using the different algorithms, the next step was to annotate and compare the results of these models by comparing with the human annotators. So annotations have done on 100 documents by randomly selecting them, and they have annotated by the different humans. So 10 different healthcare workers have shown the annotations. So each healthcare worker received 10 different pairs of randomly selected records. So the healthcare workers are supposed to assess the similarity of the document by rating them to 0 to 5. If the materials were said to be similar, if the similarity score was 4 to 5, and the documents were said to be non-similar, the similarity score was 0 to 3, and have declared the threshold for the first 50 documents and have performed the evaluation metrics on the rest 50 documents. So these are the metrics for the each individual model after comparing with the human annotations. So the accuracy of the distributed memory model was 0.80, and the distributed bag of words was 0.68, and the base accuracy for the baseline model was 0.66. This study was able to achieve the results with the doc2vec GenSim model for clustering the clinical documents. Like these vector representations have figured out how to anticipate the encompassing words in settings examined from the passage. So I have figured out that the implementation of these doc2vec models on clustering tasks, like clinical trial clustering on eligibility criteria, have proven that paragraph vector methods are competitive and have with established methods. So the clusters that have created are very important and contain exceptionally comparable trials, which is a partner to high exactness in recovering the data. However, comparing to this baseline model, the precision recall values have improved in the doc2vec models, and this can be further improved by decreasing threshold. So the main limitations for this study was is that the number of annotations, so that if the number of annotations were increased, we could have evaluated the better behavior of the model, and also while pre-processing the data, like I have go through the lot of numerical information that have been reported, like age and laboratory values and some normal ranges, so that have been removed. And also, like the future research of this study also, like it aims to build the models by separating the inclusion, by training the by separating the model by and training it with inclusion and exclusion criteria separately. This would and also these word embedding models can be integrated into the clinical trial search engines, so that it makes patients and researchers to find the trials that match their eligibility criteria. Thank you.
Thank you for the presentation. Does anyone have any questions?
Sunil, so what are the tools and libraries that you have used for handling the data in the project?
I have mainly worked with Python and also used analytical library and also GenSim libraries to perform this task.
Okay, and what was the format of the documents which you have downloaded?
The documents that were downloaded were in XML format.
Okay, thank you.
So, Sunil, I have a question. Very often we see in clinical trials that they are so broad, or that so many patients can sign in it. For instance, in breast cancer trials, patients with congestive heart failure, they sign in too, and then later, and they are eligible to sign in, but later their disease makes them fall out, and sometimes the clinical trials cannot be concluded because of the many people that withdrew from the study.
I hope like definitely employing such methods, like if a patient or researcher comes with a inclusion criteria saying that I'm looking for the trials that are open all over the world with the specific eligibility criteria, then like employing such methods into the clinical trials database, that I hope the search would be more efficient, and the researchers might get the required data for which they are looking for.
Thank you.
Sunil, and this might be sort of a very naive question, but how do you look at doc2vec and these context-free word embeddings with, say, the more popular transformer models that exist today, which are much more context specific? And so when I think of clinical trials, I think the same trial could be done in so many different ways. They could mean so many different things, even if the text might represent the same thing. So aren't context specific like transformers the ideal approach for this?
I mean, based on the literature which I have reviewed, like there were very old methods that were used to cluster the trials. I think like after researching many things, like I've seen that none of them have been employed these methods. So I tried to employ these methods initially and I'm looking to the transformers for the next step, like a BERT model, so that like I just wanted to know how models behave, like how the existing models behave on this data, so that later these models can be improved with further more algorithms.
Okay. And could you reflect a little on your metrics that you used? I see you used precision, recall, and accuracy, but how did you actually like come up with the ground truth for this? Like, did you read through all of those trials and then identify?
Exactly.
How did you?
Based on the standard, like I have created standard human annotations dataset. So I have picked random 100 documents and have made annotators to annotate them, and I have kept that as a base thing, and I've compared with my models. So in that way, I have developed the accuracy, precision, and recall values.
And what was the background of the people who annotated this? Because this is
those
a
all
very...
were the healthcare workers. Like all of them are healthcare backgrounds, so healthcare professionals.
Yeah, but are they part?
Yes,
I
they are
mean,
comfortable with the clinical trials. They are like, yeah.
okay. And when you say clinical trial, is it like a specific type of clinical trial or for like trials of any type?
Trials of any type, Professor.
Okay. Any other questions, anyone?
Yes, I do have a question. Like, how long it took you to train the model and to extract the medical?
Like actually, I have utilized this IU supercomputing resources to perform this task. So, like initially, have struggled a little bit without knowing that sources. So later on, I figured out with the help of my professor saying that we do have some resources that can help to minimize the training time, and we can do the work in very little time. So I have used IU cards and have performed this task.
Thank you.
Okay, so if we don't have any questions left, then let's move to the last presentation, which is from Sukhjit. Sukhjit, are you online?
Thank you.
Sukhjit, are you, I see you on the,
Yeah, I'm just trying to
okay.
share my screen right now. And there it is. Okay, cool. So can you guys hear me now?
Yes, we can.
All right, so hi, my name is Sajit Rasoda, and I worked with Professor Saptarshi, and my project was called Apple Fitness Share. So starting off with some background, one of the most popular and prevalent wearable health devices in the market right now is the Apple Watch. So the Apple Watch is able to track your ECG, your heart rate, your menstrual cycle, your sleep cycle, and it tracks your activity throughout the day. So that's your steps you've taken, calories you've burned, the distance you traveled, whether it's like vertically or horizontally. So wearable health devices have definitely become more prevalent, and it's because it's been proven to be increasingly helping people to better monitor their health status at both an activity and fitness level for self-health tracking, and at a medical level, providing more data for clinicians, which provides potential for earlier diagnostics and guidance of treatments. So I did a literature review for the background section, and with that literature review, it shows that smartwatches, although they're still expensive, it's not something that everybody owns. It is increasingly becoming more affordable and more available for people. So I think this app would be a really good idea since it works with smartwatches, and looking into the future, it could be a more popular thing that most people own. There are many opportunities and research potential for untapped medical information within these devices. So another big part of the literature review was looking at the Apple Watch and why I chose the Apple Watch to focus on. And with these reviews, Apple Watches were constantly being called like the best one, the most accurate one. For example, one study was comparing the data from your Apple Watch compared to a hospital. So your Apple Watch can see your ECG, it detects that. And it compared that ECG to one that would be recorded at a hospital. And it was shown they're comparable, they're very accurate, and you guys would be able to use that for actual usage since it is an accurate device. The main objective is to be able to gain more benefits and data from the information that is being tracked by the Apple Watch. The Apple Fitness Share app would be a unique app in the market that would allow integration of both Fitbit data and Apple Watch data. So this would be especially useful for those that own both, because as Fitbits and Apple Watches are made, they aren't made to be interoperable. So this app, the Apple Fitness Share app, could be one central place where both the data can go to, and it can be beneficial for people with both devices. Another advantage of this unique app is that it allows for that central storage of raw data. And having that data stored in an app like that, it would be helpful to be able to detect patterns, to detect anomalies, and other significant data that you might not actually be able to recognize with just your watch. The purpose of this project is to create an app that connects the data from a fitness device with an electronic health record, also known as EHR, in order to gain more information and data from the analysis of both devices. You guys can see on my presentation, I have a little flow chart, and this kind of shows the potential for the Apple data. So it starts off at level 1, which is just raw input. So it's going to be like, oh, your average heart rate is 72, just things like that. And as that data is processed, it can go all the way up to decision making. We're able to make diagnosis. We're able to use it for monitoring and maintenance. I think this flowchart's a really good flowchart to show the potential that the watch does have when it is further analyzed and things like that. So the target audience for this project are health informatics specialists, health professionals, and then users and patients themselves. So if you do own a wearable health device, I think you'd be a great audience for this, or if you're a patient looking into buying one as well. So the method that was approved was working upon a pre-existing app. So this pre-existing app is called Fitness Share, and it was never launched because it was never completed. And this existing app would be a great foundation for my app since it's very similar in basis. So having an existing app like that helped me start off with a basis, but still gave me lots of room to make my own changes and tweaks to make it specific to my project itself. So to start off the project, the first thing I had to do was actually gather that raw health data from your Apple Watch to see how it is, like how it's presented, how to be able to use. And if you guys have an Apple Watch, probably know this already, but the data is stored in your watch, but it's mostly stored in HealthKit, which is kind of like from your iCloud and stuff. And HealthKit is an app on your iPhone. So in order to get that data, you would just go on your iPhone, go on HealthKit, and you export that data to your email or to your messages. So I emailed it to myself and it came in a form of an XML sheet, a very large XML sheet. It was full of lots and lots of data. Since the Apple Watch doesn't only detect health stuff, it also gets your phone calls, it also gets your texts. There's lots of information within that little XML sheet. So what I had to do with that really large XML sheet was transfer to a document with only relevant data. To do this, I had to use an extensible style sheet language transformation, XSALT. This would allow me to transform that original very large XML sheet to another XML sheet that only has all the relevant data. For example, the ECG, your heart rate, steps, sleep patterns, and things like that. With a transformed XML sheet that only obtains the relevant information, the next step was doing a share with plugin. So this was necessary for my project because the share with plugin was going to be what connected my app to the HealthKit app in order to get the information transferred. So programming the share with app was going to be helpful because not only would I be able to import information from the HealthKit app, but if you had a Fitbit, the Fitbit app would be able to do that too. Speaking of programming, I utilized Cordova and Xcode for programming and coding. I chose to use Cordova because it enables software programmers to build hybrid web applications for mobile devices. And it's also a lot more flexible because it allows you to use HTML, CSS, JavaScript, rather than using a different language that would make you only use platform-specific APIs. So while I used Cordova, I was also using terminal in conjunction with it since I was on a MacBook. And the terminal allowed me to use Cordova. And also I was using Xcode because I found Xcode to be the easiest platform to be able to see the coding and be able to run the codes on a simulator and things like that. You can see that there have some screenshots here. So this right here in the bottom left app, that is the FitnessShare app itself. And these apps, these screenshots down here show like a login page for your EHR and being able to retrieve your health data. So although the Apple FitnessShare app shows up, it wasn't completely functional at the end of the day and is unable to achieve what the project set out to do. So this project does need further research and programming for it to reach its full potential. And I think there were a few limitations that prevented me from getting to that potential. So the first limitation I would say is limited access to data. Although it's very easy for you to obtain your own Apple Watch data by exporting it to your email, the share with plugin, what I wanted from that app to go directly to my app was not successful. Although I did a literature review of other apps and it was possible before, there is not current research enough for the share with plugin. So the share with plugin did work with my app, but it was limited to just videos and photos, and it was not compatible with HealthKit, which was a big hindrance to my app. Another limitation was time constraint. This comes with just like coding and doing all my research and stuff. Coming from a health information management background, I don't have a very big coding background. It's very much more on the management side. So having extra time to progress my coding, getting more progress and increasing my expertise in JavaScript and Cordova would be very helpful. So although, as I mentioned, the app wasn't successful, I definitely think it's something to keep looking towards. There's lots of applications for this app, the main application being healthcare as mentioned. This app would be most beneficial and useful when being used to look at those healthcare trends. Being able to connect your Apple Watch and health data to your electronic health record will help for predictions and it will help for precautions regarding your health. Another suggested application are those that are trying to go through a weight loss journey or just a fitness journey in general. So you'll be able to see your progress and you'll be able to see patterns through the Apple Share Fitness. And this is going to help people make choices about their lifestyle. For example, if someone's like tracking their like heart rate and stuff and they started going to the gym more regularly, they could physically see, oh, look, a pattern. My average heart rate used to be 76 and now it's 74. You're able to see like actual progress like that in an easy way. They can also use this app to help make health decisions and help decide when they need to contact a healthcare provider. It can help make those patients and users feel more empowered. The overall application of the app would be gaining more information from all the health data to help make the best possible health decision. I believe continued research and work on the Apple Fitness Share can help create a useful app that can help connect the health data with their healthcare providers, and in the end being able to empower both the users and the providers with that health information. Thank you. Do you guys have any questions?
What are the security concerns around using this app? When you were developing it, how did you think about those and think about incorporating it? Or
Yeah.
is that something you're going to consider down the road?
Definitely a good question. I did look into it a little bit. So I made my own privacy policy and things like that for the app. So with that policy, kind of tells you, hey, we're going to be taking your data from here and using this data as well. So we make our users aware of like what security issues, privacy issues are. We also tell them like what we're providing for privacy. So like in the like policy I wrote, like your information will be safe. It will be like this, but I would have to implement like something electronic, like some sort of like firewall, something like that to actually make it safe. But I did look into privacy and security. And I have like a section in my report with the actual privacy policy.
I have a related question to that.
Yeah.
Who owns the data? Apple, the user, or the EHR, the hospital?
The Apple Watch data? I don't know if this is like one answer is right, but
No,
I would
there's
say,
no right answer because it's a big issue with the government going on in sharing data from the data ownership.
I would say it is the user's data, but when you use apps like such as this app, maybe it would be like a priority that the hospital needs to have like some sort of ownership of the data. So I think purely the Apple Watch data is the users, but when you use other apps or connect to other stuff, then it kind of like.
How are you sure that Apple cannot erase the data and not make them unavailable to you?
Apple can do whatever they want, I feel like, but I feel like there is like no, like it hasn't happened before, and it isn't something that like is.
No, but we need to think about the data ownership before we really implement it in electronic health record. Because if you make clinical decision and it disappears, then privacy and security.
Yeah. Okay.
Thank you.
Thank you.
I have a question.
Yeah.
About your background section. You covered that providing more data to clinician with the potential to area diagnostic and guidance for treatment. So I did a little research about the same topic, and I found that most studies state that reported that clinician did not find that the information is useful, and they complain about wasting their time because patients insist that they review their data. So I'm interested about your finding about this question.
Yeah. So I did find similar things to yours too, where it was like it's not super beneficial. Like it's still not what you really need in person. But there were the reports that I did find, they found a lot of things about cardiovascular health diseases. And with that, I think ECG was the biggest thing that they were like looking at, in heart rate. They were able to see like being able to detect things where like, oh, you need to go to the hospital now. Oh, you need to call your health care provider now. Oh, you need to do a certain thing now. So I think the biggest success that I saw in my literature review was for predicting cardiovascular diseases with the ECG and heart rate.
Thank you.
Yeah, thank you.
Are there any other questions?
All right, thank you.
Thank you all for the wonderful presentations, and thank you, Dr. Purkayastha, for organizing this for us. We are glad that we have 7 new graduates to go out in the world. Congratulations all, and we hope to get your revised paper in soon.
Thank you for all the professors for guidance and support all the time. Thank you all.
So now you can all take a deep breath. You're done.
Thank you, Professor.
Thank you.
Thank you. It was a lovely
you.
evening listening to all this great work and presentations. And good luck.
Thank you.
Thank you. Bye-bye.
Thank you. Have a great weekend, everyone.
Have a great weekend, everyone.
You too. Bye-bye now.
Bye.